Okay, and now we're recording. And thank you all for those who are watching this after the event of joining the LeedsAzure user group. We are joined here by John Craddock, who is a Microsoft MVP in the identity space. I will let John introduce himself and tell you about what he's going to be presenting to us today. Over to you, John.
Okay, great. Thank you very much and welcome everyone. So as Ryan said, I'm John Craddock. I'm based in the UK, down in the very bottom of England. So I'm just outside Brighton. I have been in the identity space for many years. I did an awful lot of work at one time with on-prem Active Directory. I actually worked very closely with Microsoft right at the, before on-prem AD even sort of saw the light of day. And I presented for Microsoft at the launch party for AD 2000, and that was in Geneva and the States and all over the place. Since I started with identity really in AD. I got very much involved then in federation, and I've worked with lots and lots of organizations providing federated identity solutions. And I've also worked with Azure since it started as a conception. So what I'm going to talk about today is FIDO2. And although FIDO2 integrates beautifully with Azure AD, it also provides us an identity solution which is internet scalable. And the idea with FIDO2 is that we can go passwordless. And what I want to do is start off with looking at how passwords are a problem. We all know they're a problem, but what I want to be able to do is go through these problems later and say, well, FIDO2's got rid of that one, FIDO2's got rid of that, FIDO2's got rid of that, and so on, and show you how FIDO2 really eliminates most of the password problems. We'll look at going passwordless. So I'll start with a sort of gentle introduction to that, and then we'll get down into the nitty gritty under the hood. I will show you how it's set up in Azure AD, but I want to keep this very much as a sort of generic FIDO2 session. So we're going to go in under the hood, and then finally, we'll have a look to see how FIDO2, Windows 10, and Azure AD sign-in all integrate together. So the session's around about an hour. If you've got any questions, by all means ask as we're going through. Put it in the chat window. When I do a demo or something like that, I'll stop, have a look in the chat window and see if there's anything to answer. Otherwise, hold the questions till the end and we'll spend a bit of time right at the end doing a Q&A. Okay, so let's get started. So the big problem with passwords is that they are shared secrets, and also users are involved. So our user has to create an awesome secret. Well, users are horribly predictable in the way that they do that. So here's this character created a password of fall 2019 exclamation mark. I wonder how many COVID-19 passwords are out there today. So we think up a password which should be strong. And the next thing is we give it to the relying party. And the relying party says, don't worry, I'm going to store it safely for you. Now, a relying party could be a website. It could be a security token service of some kind, an identity provider. So it could be, for instance, Azure AD. Or it could be some federation using ADFS, using ping, using Okta, and so on. Okay, so we give the shared secret to the relying party. So our first problem is, of course, that our user thought it up and they produce really simple, predictable passwords on the whole. So it makes the account immediately susceptible to spray attacks. And spray attacks are about picking low-hanging fruit. What you do is you take a predictable password and you spray it across multiple accounts. So you're not seeing one account being attacked, you're spraying it across a whole landscape of accounts. And the chances are you will be successful. Some of those accounts will be using simple passwords. The other possibility, of course, is a brute force attack. Much easier to see a brute force attack going on than a spray attack, and we are actually attacking an individual. Brute force attacks don't happen very often. They'll only happen if you are trying to attack an individual. So spray attacks, picking low-hanging fruit very easily. Then, of course, the next thing is those relying parties are on a very regular basis being breached. And if you're not familiar with it, go to haveibeenpwned.com. And the last time I looked, which was probably when I put this slide together, which was a couple of months ago, 438 pwned websites. So those websites have been completely overtaken, and 9 billion password accounts. So that's usernames and passwords that have been taken, and many times the passwords are held in a very simplistic form, and it's very easy to reverse engineer them to clear text. So as soon as we get the usernames and passwords compromised, they're published on the dark web, somebody buys them and immediately does credential stuffing. And what they're doing is they're simply using the credentials that have been found on the dark web and just playing them against other sites. And there's a huge number of credential stuffing attacks. There's a huge number of spray attacks that go on a very regular basis. Brute force does happen. It happens less often. But, you know, if we're looking at just picking low-hanging fruit, those are our problems. The next thing, of course, is users, if they're not getting their emails, are very sensitive to that. And this looks quite interesting. It's coming from the Office 365 message center, and it's saying, oh, you've got undelivered emails. Multiple emails are pending. Please update your delivery preference here. So you click here, and immediately it takes you to your corporate logon. And, you know, being you know, a good citizen, what you do is you look at the URL and you can see the padlocks there, so you know it's using HTTPS. Log microsoftonline.com, that sounds very genuine, but that particular website I could have bought the other day, log microsoftonline.com, for just 99 pence. I could have then screen scraped your corporate logon. So I could have got your logon logo, built a logon dialog, which has been screen scraped, and then I've got your credentials. So doing attacks like this is a big problem. And then of course there's password resets. And quite often what you find is the password reset information has been basically given away by people putting that information on social media of some kind. That's if you're using a password reset via a knowledge-based authentication, so a KBA, security questions and answers, or alternatively, of course, you could be resetting the password via an account that has already been compromised. So lots of places where we can attack people with passwords. Challenges, of course, is number one, educating users about password security is difficult. It's extremely difficult. MFA, absolutely, you need to turn on MFA, because what it's going to do is it's going to immediately eliminate 99.9% of sign-ins with compromised passwords succeeding. So that's where the username and password's being compromised, and this is your next step block. In a lot of cases, simple MFA is going to be sufficient, because what the attack is for low-hanging fruit. All right, so we're not targeting a specific person. If a specific person is being targeted, then I would strongly advise against MFA. So for high value accounts, think about alternatives to MFA. And one of those alternatives, of course, is to use some sort of authenticator app where we have actually bound the identity of a device into the MFA as well. The other thing is to be very, very careful with is don't over prompt for MFA. If you over prompt, and there's a huge tendency in this, and particularly in the Azure AD space, where now you can control session times via a conditional access policy. If you over prompt, people will start just going to their authenticator app and clicking yes, accept. All right. And so before you know it, they've got into the habit of just going, oh God, I'm being prompted again, accept. And you never know, they might be on a beach. Oh, I'm being prompted, accept. And of course, what you need to do in terms of education is tie people up to say, look, never approve unless you are actually being prompted to log in. But if you're using things like, if you're using things like Outlook client, the Outlook client's running on your desktop, and suddenly you get an approval come up, you don't necessarily see, the prompt from Outlook, and the challenge is people will just approve. So how do we eliminate passwords being compromised? Well, the thing to do, first of all, is to eliminate shared secrets. Shared secrets are unbelievably dangerous. Number one, because a user makes up a very simple secret. And number two, because can we really trust the other entity that we've shared the secret with? Azure AD have done a very, very nice job with passwordless sign-in. And so here what we do is we go to approve the sign-in, and what we'll need is our authenticator app to do that. And sitting on the approval dialog is 41. And what we have to do is select 41 on the actual application. And once we've done that, we've logged in without any passwords. The great thing about using the fact it puts up a numeric value and we have to select that value means absolutely 100% we tie your action on the Authenticate app to the login prompt where we're approving the sign in. So there's no sort of doing this and going, oh yeah, oh gosh, not another prompt and just saying approve. So we are tying the two together. That works beautifully. But if we want to scale passwordless operations across the whole of the internet, we need something that's totally standards based. And there was a mission from the FIDO Alliance, which was the Fast Identity Online Alliance. They were founded back in 2012, and they had a mission which was to eliminate passwords. So they wanted to come up with a passwordless authentication protocol. In December 2014, they actually published two protocols. One was Universal Authentication Framework, or UAF. The other one was the U2F, which was the Universal Two-Factor Authentication. U2F actually gained a lot of popularity, and Google were a major player in the U2F space. And but UAF, which was the complete passwordless protocol, didn't gain a huge amount of popularity. In 2019 was very, very significant because in 2019, the FIDO2 protocol, the core authentication protocol within that, which is Web Authentication Protocol, or WebAuthn, was adopted by the World Wide Web Consortium as an internet standard. And as soon as that happened, it immediately opened the floodgates for vendors to say, hey, we have a standard. We can come up with FIDO2 security keys. It also allowed Microsoft to make some changes to Microsoft Hello to become certifiable as FIDO2 compliant. Microsoft with Microsoft Hello have always tracked FIDO2 very carefully, but this now in 2019 they became certified. So you can actually authenticate to a FIDO2 website using Microsoft Hello. So nothing to do with Azure AD at all. We can do it with Hello, and I'll come back on that. So the floodgates opened, and there are lots and lots of keys out there. Feitan keys, Golden Gate keys, they all come in different sort of form factors. Yubico are very much to it in the key space, and down the bottom there's a sort of smart card form factor as well. So how does it all work? And I'm going to start off by actually sort of introducing the ideas, and then what I'll do is I'll come back and go in under the hood and look at the actual details. But the idea is we eliminate shared secrets. We eliminate the need for a user to create a secret. So we have the user sitting at the browser, and we have our relying party. Now, remember, our relying party could be an IDP as an identity provider, such as Azure, or it could be just a website. So you can implement this and just implement it in a website. So the first thing that happens is to go with the platform the user's working on, we have a secure store. And in that secure store are relying party identifiers. So here's a relying party identifier, example.com. And associated with that is a private key and a public key. The private key, public key pair are generated within the secure store, and the private key never leaves the secure store. So it always remains there. We start, we need to do what's called registration. And as part of the registration process, what we're going to do is provide the relying party with the public key. And the relying party doesn't have to know the user's identity. It can it can store the user's identity as a random identifier. So the fact that it's John, we don't need to know it's John, because John could log on to lots of different websites, and now he can have a unique pseudo-anonymous identity on each website. So there's our user, there's our relying party. Next job is we send a signed message, and the signed message is signed with the private key. And the private key never leaves the user's possession, but we've signed the message. So it's come out of the secure store, it actually remains in the secure device, signs the message, and we send it across. Now, the receiver of the message, which is the relying party, what they can do is validate the signature using the public key that was previously registered. And what it tells us is 100%, it tells us that the message hasn't been tampered with. So by validating the signature, we also validate the integrity of the message. And having validated that, we can now know it's not been tampered with. And what else can we tell? We know 100% that the sender is in possession of the private key. And remember, the private key never leaves the possession of the sender. So we know if that sender comes back to us, we know it's exactly the same person that registered with us in the first place. Okay, now quite often I'm asked, how does the crypto signing and verification work? So I put together a slide to sort of take you through that. And what happens is we end up with a signed message, which consists of the message and a signature to go with it. There are two actors in this. There's a signer and there's a verifier. And what happens is the signer takes the message, they get it ready to transmit it. They're not encrypting it, they're just getting it ready to transmit. And then they take the message and they pass it through a hashing function. And what a hashing function does is it takes the message and it produces a fixed length digest or hash value. Okay, so regardless of the size of the message, that digest will always be the same length. And because of the crypto maths that's used, the chances of two different messages coming up with the same hash value, having gone through the hashing function, is for all practical purposes 0. It's not impossible to have a clash, but you can consider the chances of having a clash for practical purposes 0. So now we have a unique hash of the message. Our next job is to take that and to encrypt the hash using the private key that never leaves the signer's possession. We now put that signed hash value as the signature. The verifier receives the signed message. Well, the first thing they do is they pass it through exactly the same hashing function and they come up with a hash value. Now, if the verifier's hash value matches the signer's hash value, then it means the message has not been tampered with. So how do we verify that? Well, what we do is we take the signature and we decrypt it using the public key. The public key was previously registered. Now, we then compare the hash value that we've just calculated, the verifier's calculated, with the hash value that has been derived from the message by decrypting the signature. If the two match, it means two things. Number one, the message has not been tampered with. And number two, the signer was in possession of the private key that is associated with the public key. So that's the process, and that's how it operates. So when it comes to FIDO2 authentication, number one, what's happened is we've actually gone through a process of registering with the site. Again, we'll get into the details of that. We then inform the relying party in some way that we want to sign in. And what the relying party does is it sends us back a challenge. And we have to take that challenge. Can't do it in the browser because the browser is not going to be able to sign that. What it has to be done is passed to an authenticator. And the user can verify themselves to the authenticator. And they could do that verification either using a PIN or a biometric. Having done that, what the authenticator can do is look up in the secure store, which is probably inside the authenticator, and look up a private key that is associated with that relying party. So in our particular case, the relying party is example.com. So we look down there, example.com, private key is AA. So what I'm going to do is I'm going to take the challenge and I'm going to sign it with the private key, and I'm going to send it back to example.com. And we get back the response coming back, and the responses arrive back. And what we can do now is verify the response with the associated public key for that particular user. Now, the sign response is actually called an assertion. So remember that is an assertion, not to be confused with an attestation, which I will come to shortly. Okay, so that's it. That's just got us signed in. So if you want to set up a FIDO2 key to use with Windows 10, then what we do is we go to security key, and then we go into set a PIN on it, set a fingerprint, we can reset it there, and so on. If we want to use it with Azure, what we have to do is, number one, enable it to be used with a particular account in Azure. And where in Azure, what we do is we go to the authentication method policy. At the moment, it's FIDO2 security keys we can set up, and the Microsoft Authenticator for passwordless sign-in. In the future, expect to find this is the sort of portal for doing MFA, self-service password reset, and maybe turning off passwords completely in Azure AD. Now, the beauty of this is we can say, I want to use FIDO2 security keys, so I can enable that. And down here, it says the target, which is all users or selected users. So if I go for all users, then obviously it turns it on for everyone. Everyone could use FIDO2 keys. If I use selected users, then a group of users. In the future, we can do allow self-service setup. And notice it says enforce attestation. That's not an assertion, that's an attestation, and I will come back to the meaning of that very shortly. So what I want to do is just do a quick demo of registering a key. So I'm going to go across. Actually, I'm going to have to register the key. Let me drop out of the presentation. And the first thing I'm going to do is I'm going to go to security and set up a security key. And I've already got a security key that's in here. And what I'd like to do is reset it. And when I reset it, basically it flushes all of the key materials that are in there. So I click on manage and it's saying touch the key. Now, when it says touch your key, there are two things that it could mean when touch your key. Touch your key to prove you're there, or to touch your key to actually be verified. Depends. If it's a biometric key, we can actually have verification. Here, it's just saying prove you're present. So I'm just going to touch the key, proved I'm present, and now I'm going to go and reset my key. Proceed. Again, touch your key, prove you're present, and could not complete a security key reset. Okay, and you go, what on earth have I done wrong? The thing is, you can only reset a key within 10 seconds of powering it up. It would be such a simple thing for Microsoft to put a message about you need to reset it within 10 seconds of powering up. And I have put it in as a request to Microsoft. So I'm going to cancel that. I'm going to remove my key. I'm going to plug it back in. And I'm going to go reset it. Proceed and touch it. And reset complete. Okay, so now I've got no key materials at all on my key. So now I go to set up a fingerprint. I can't. It's a biometric key, by the way, this one. I can't do it. So what I need to do, first of all, is put in a PIN. So I need to. So even if it's a biometric key, I will need to set a PIN. I can now set up a biometric. So I go to do that, and I touch it, and I touch it again, and what it's doing, it's taking multiple reads of my fingerprint, and very shortly, it should have got fed up with me. And okay, now again, there is no way here that you can actually test your biometric on your key. And again, I've asked that, as it would be very nice if I could click here, test biometric. I can't. So I'm going to have faith this thing's going to work. Okay, so we can close that off. We're done with those options. And what I'm going to do now is I'm going to go to My Applications, which is the My Apps portal. And I'm going to sign in as a user. Let's actually make that full screen. I'm going to go in as a user, John. And the rather strange domain name is because I use this, it's a user domain name in a masterclass I run. And the 5.ad is actually n.ad, which is your value of n. Okay, so I just need to remember my password, which I have done successfully, which is good. This, if you're not familiar with it, is actually the My Applications portal, which is the replacement to My Apps. I'm going to come in here now, and I'm going to view my account details. And I'm going to go to security information and update the security info. And what it's asking me for is second factor. So I've got that set up. So 7784189, 7784189. Hopefully I got it. It just flashed up on my thing. Okay, so now I've got a phone, MFA, I've got email as a sign-in method, and I'm going to go add a method. And rather than using the Authenticate app, I'm going to use a security key. So I'm going to add the key. Next on there, and it's saying, is it USB or is it near field communication? It's actually USB. It can, FIDO2 will support Bluetooth Lite, which is not implemented in Azure at the moment. So I'm going to go next on there. And hopefully after a few thoughts, right. What it's saying is use your security key with login.microsoft.com. A record of your visit to this site will be kept on your security key. Okay, I'd like you to remember that. I'm going to come back to the reason for that later. So I'm going to continue on that. Touch your security key. So this time it's going to do a biometric read. And then it's saying, allow this site to see your security key. Loginmicrosoft.com wants to see the make and model of your security key. I've mentioned it a few times. That is attestation data. Again, I will come back on it. I'm going to allow it. And now I need to give my key a name because I will probably have a number of keys registered. So I'm going to give it a name, which is key 1, and I'm done. So now what I can do is I can actually let's close the browser and go back in again to my applications. And now the beauty of this is I don't need to supply the username. It's passwordless and nameless. So I'm going to say use another account. I'm going to choose sign in options and I'm going to sign in with Windows Hello or a security key. And what it's doing is I'm going to choose down here security key because it will sign me in with Hello, but I'm going to go security key and make sure it's you. So I'm going to touch it. And when I touch the key, I am being verified. And that's it. I am signed in. And that now I've got a FIDO2 key that can be used with Azure. Okay, let's have just a quick look and see if there are any questions. That's weird. I've lost the. Here we go. Anything in the chat window? Not at the moment. So hopefully it's coming across okay. So what I'll do is I will go back to the slides. Do remember, if you've got a question, by all means, ask away. Okay, so I'm going to, I've done this, the demo of registering the key. I've got my, so top tip, could not complete the security key reset. So do remember that you've got to plug in within 10 seconds. And then I've got a little video here which actually shows you the Golden Gate G310 key, which is a USB key. What it's doing now is waiting for input. So if I, so it's showing key ready here. If I touch it with the wrong finger, okay, so it's waiting for input there with the blue, sorry, green was ready. It's failed to read. That was the wrong finger. Now I'm touching it with the correct finger and it's successfully read my fingerprint. So when it says touch the key, it's actually, in most situations, it's saying verify the user, use the biometric. If you fail to use the biometric, what it will do is it will revert to using the PIN. Okay, let's get into some detail under the hood. So the components of FIDO2. So you have a browser, and inside the browser is going to be some client-side JavaScript. And that's been served by our server app, which is running and on the relying party. excuse me 1 second. I'm just going to just take a sip of water. Yeah, I could just hear feel a cough or a tickle coming on. Okay, so we got the browser, we've got the client-side JavaScript running inside there, which has been served by the server app. This is using the WebAuthn registration and authentication protocols. Inside the browser, we have some APIs, and for some reason, hold on 1 second. I just haven't clicked back in that window. Yeah. So inside the browser, we have APIs. Actually, I managed to click. Okay, I think I'm back in action. Can you hear me? Is anyone, Ryan?
Yes, we can hear you fine.
Good, great, thanks a lot. Okay, so we have WebAuthn APIs inside the browser, and all the modern browsers now support the WebAuthn APIs. And this is the beauty thing about having this as an internet standard. So they, in turn, will talk to the authenticator. And the authenticator could be a roaming authenticator, or it actually could be a platform authenticator. When they talk to the roaming authenticator, they're using a protocol which is referred to as CTAP, the CTAP1 and the CTAP2. And what CTAP will allow you to do is talk to a roaming authenticator using near field communication, using Bluetooth Lite, currently not implemented in Azure, or using USB. Why CTAP1? Well, if you remember, I said the original U2F protocol allowed you to do two-factor authentication with FIDO. Now, there's an awful lot of keys out there, and U2F is supported via the FIDO2 protocol. But when you're talking to one of those keys, what you'll be doing is using CTAP1. So effectively, CTAP1 is U2F, where CTAP2, which is client to authentication protocol, is used for your FIDO2 keys. And then, of course, you could be talking to a platform authenticator API, and we could be using TPM, we could be using Windows Hello in there. On the server side, now, if you remember on the server side, what we need to do is store the user identifier and the public key for the user. So we're going to have a key store over there. So we're going to have library APIs to support all this. Now, the other thing that you can have is the roaming authenticator can tell you about itself using attestation metadata. And what we can do is we can verify the attestation data against an attestation trust store, which could be as part of the relying party, or it could be external. So the FIDO Alliance has an external metadata service. So in this way, we can verify the details of the authenticator. Now, you're thinking, wait, when might we use that? Well, if you're just building a website, you might not care what authenticator is being used. But if you were a bank, you might say, hang on a minute, I only want a particular type of authenticator to be used. Or if you are the admin or security officer for your organization, you might want to say, yeah, I'm happy with that authenticator and that one. And yeah, okay, that the third one as well. But the rest, no, I don't want to use them. Or you could say, I'm happy with most authenticators, but I want to block one. So this is the beauty of using attestation metadata. Again, I will come back and we'll see how we block it shortly. So 2 ceremonies I told you about. There's the registration ceremony, and then there's the authentication ceremony. So if we look at the registration ceremony, we start off with talking to the relying party and saying, you know, we want to register, and how we get to that stage, I will come back on. But somehow we trigger the registration process. And what the relying party will do is it will send us a create credential. And the create credential is actually a really powerful command. And we're sending that to the client, which in turn will get sent on to the authenticator. But if we look at the details of that create credential, one component will be a challenge. Now we use challenges all the time when we're actually registering and also when we're authenticating. And it's a random string of bytes. We use it to prevent replay attacks. We can also send back the challenge signed form as well. The next thing is we send a relying party ID, and that identifies the relying party's domain. So now we're connecting to a particular service, and this service is saying, I am, okay, and it could send back the domain name. So I am xtshub.com, and that's a relying party identifier. Okay, so it's sent that back. Then it generates a random ID for the user, and what that's going to be used is to associate the credential with a particular user. It will then declare the public key credential parameters, so the crypto types of public keys that are acceptable to the relying party. So that can be declared. The next thing is we can set the authenticator, the type of authenticator. We can say we only want you using a platform authenticator. It's also referred to as a bound authenticator. So that would be, for instance, Windows Hello using a TPM. We could say we only want you to use a roaming authenticator. Well, then we say that's a cross-platform authenticator. Or we can say we don't care. Right, so we can choose. So this, remember, is as part of the registration ceremony, the relying party can specify the type of authenticator. We can then say whether we want the private key to be residential or not on the authenticator. Now, I said the private key never leaves the user. Well, of course, it's actually inside the authenticator. So it never leaves the authenticator, which only the user has access to. Right? That is sort of true, but not completely true. Because what we can do is, instead of having a residential key that never ever leaves the authenticator, what we can do is we can generate a private key, and then we can encrypt that private key with a private key that never leaves the authenticator. And we can give that encrypted private key back to the relying party. So think of the two-factor authentication scenario. Here we log on with a username and password. The actual relying party checks out that that username and password is correct. It says, yes, I believe you are John. And look, I have this wrapped key for you. Of course, the only person that can unwrap it is the genuine John with access to the genuine John authenticator. So I'm going to pass it back to you. So at that point, we can pass back the wrapped key, and the authenticator can unwrap it and then use that private key for signing. If you're going nameless, then we don't know who the user is. So we have to absolutely use residential keys. And most of the time, if you're doing passwordless, you'll be using residential keys as well. So that's the type. The private key could be residential, or the other term for it is wrapped. And then the next thing is user verification of the authenticator required, preferred, or discouraged? Again, if you're doing two-factor authentication, remember it's something you know and something you have. So all you need to do is prove you have the key. You just touch it, and it's saying user is present. So we just touch it, and therefore we could just use, we could go discouraged. We could say, alternatively, what we can do is say you have to authenticate to the authenticator or verify to the authenticator, in which case it will be biometric or it will be using a PIN. And then timeout. Timeout is just when it all gives up and gives you an error message back. And that value can be set. And then the next thing is we say whether the relying party requires attestation data or not. Remember, it's a relying party thing. It's the relying party saying, yes, I care about the authenticator you're using. You can only use a particular authenticator, or I don't want you using that authenticator at all. In which case, if you want to do that, then we need the attestation metadata being returned. So, as I say, quite complex, but very flexible. So our next thing is we pass the, with the create credential, our first check is we are going to look at the relying party ID. And the client is actually connected to a relying party and it knows what the origin is. So if we are genuinely connected to the relying party, and let's say the relying party is xtshub.com, then what the client will see as the origin is xtshub.com. But if a man in the middle has got in there and we're actually connected to xtshubs with an s.com, so they're trying to spoof us to actually coming to the rogue website, what will happen is the client will say, my origin is xtshubs.com. The relying party tells me that the identifier is xtshub.com, and immediately it rejects it. So what's happened is we've just straight away eliminated the man in the middle attack. The next thing is we pass all of the information across to the authenticator. So we're talking from the relying party to the client, that's WebAuthn. From the client to the authenticator, if it's a roaming authenticator, we're going to be using CTAP. And if it's FIDO, it's going to be CTAP2. So next thing is the user. We have to verify our user. So we do that. It will then generate a public-private key pair. The private key will never leave the authenticator unless, of course, we're not using resident keys and we send it back as a wrapped key. But it will never leave the authenticator in a usable form. The next thing is we're going to create a credential ID, which will be tied to the credential ID the relying party has given us as well. And we're going to securely store the private key. Next job is we're going to build a signed response. Now, there's no point in signing it with our private key because the relying party doesn't have a clue, right, what our public key is at the moment. Right? So what we can do is we can sign the response with the attestation private key. Now, that attestation private key is not unique to an authenticator. It's unique to a range of authenticators. So if you've got the G1475 key, then the G145, whatever I said it was, key will have an attestation private key, which is unique to that range. The reason is that we don't have a unique key per authenticator is if we did, then we could easily track someone by identifying the associated public key with the signed material that's sent across. So we then send that lot back to the relying party. And what the relying party is going to do is it's going to verify the origin, it will verify the challenge, and it will then, so the challenge has come back, it can then verify the attestation signature, it can check the attestation to root trust because it is the attestation can be with a fully trusted certificate to root. All right, that's not root of the sort of it would be the root of the metadata for the FIDO alliance, We then, having got that information, having verified everything, we store the user ID, we store the credential ID, and we store the public key. So that takes us through the registration ceremony. The FIDO Alliance metadata service is where we can validate the metadata. And the beauty of the metadata is that we can find out the characteristics of a particular authenticator. We can even pick up the icon for the authenticator, a little PNG of a picture of the authenticator, so we can relay that back to the user if we want to. So using metadata, we can make risk-based decisions about a particular authenticator. How the authenticator is identified, they're identified by what's referred to as an authenticator attestation GUID or an AA GUID. And we can say during the registration, the authenticator signs the response with the attestation private key burnt into the device, but not on a per device, on a range or a model of devices. In terms of verifying the attestation signature, you can, if you want, take it all the way to root. And if you remember that switch in the when we were, and we'll see it again shortly, the switch where in Azure AD, we can actually verify and say we've actually got to have a verified attestation all the way to root. Alternatively, you can allow self-signed attestations. Some relying parties are going to actually rely on the veracity of the TLS tunnel. It's going to say we've got it from a source, we've got a TLS connection to it, and we're not going to verify it all the way up to root. Others will fully check the signature as well. And so the Microsoft Azure AD has this thing called force attestation, and it verifies it all the way. Switch it to no if you want to use self-signed certs. There's just an example of some attestation metadata and the AA GUID for, in this case, for Yubico, and I've also got the AA GUID for the Golden Gate key as well. Now, two things. Those messages that popped up in the browser, a record of your visit to the site we kept on your security key. That is if you want to use a resident key, and then allow this site to see your security key is when attestation metadata is being asked for. When I used Azure and registered it in Azure, you saw both of these pop up in the browser. This was I was using Chrome. You'll get a slightly different pop-up in other browsers, but this is for Chrome. Now, how do we identify the user? Good question. Maybe you don't even want to identify the user. You don't care who the user is, and you can do trust on first use. What happens is when that user registers, what they're going to do is they're going to give you a public key associated with their private key. And having done that, right, when that user comes back again, right, what you know 100% it is the same user, but you don't necessarily know who they are. Right? You may just want them to log in so you can hold a profile for them. So you don't care if they're John at XT Seminars. You don't care anything about that. It's unlikely you'll want to go that route in a pure trust of first use, but that's one of the ways you can do it. The other thing, you can go through an invitation process. So I can send an invitation in advance of a registration. That invitation could be via email, or it could be via actual mail that is delivered to somebody's house, so you can verify their home address or their business address. And then what they can do is they can have a code, which when they start the registration process, they put their code in. You can do full-blown identity proofing. Somebody actually has to come and register with you and prove their presence, and maybe bring their passport and all sorts of other bits and pieces. Or you can bind to an existing credential. And that's what happened in Azure AD. I actually bound the security key to a strong authentication which had already used MFA. Remember, the private key never leaves the authenticator, so there's no way you can back it up. So if somebody loses the authenticator or the authenticator gets damaged, they can no longer log in using the authenticator. And if you've turned off passwords, that could be a little bit annoying. Right? So what you have to do is you have to go through a completely new identity proofing or binding to an existing credentials, whatever you want to do, and you have to have a recovery policy. The other thing, of course, is to have multiple authenticators registered on the account for recovery, which of course you can do. And that's why we named our key. When it comes to authentication, relying party is going to send relying party ID, credential ID, a challenge. Immediately, we're going to verify the origin, checking that there's no man in the middle. So the client sees a different origin to the relying party ID, we simply reject it. Otherwise, it gets passed through to the authenticator. The user verifies against the authenticator, retrieves the private key, and then verifies the credential was created for the particular relying party, and then builds and signs the response with the credentials private key. We then send that back, and then we can go through the verifying the origin, so no man in the middle on the way back, verifying the challenge, has the challenge come back, verifying the credential ID, is that the credential ID we expected, and then of course verifying the signature with the public key. And if all that's okay, we're in. So let's just do a quick demo of registering and authenticating. And what I'm going to do is I'm going to actually use a different website. I'm going to use WebAuthn.io. And what this is, it's a website sponsored by Duo, but it allows you to play with FIDO2 and registering things. So I'm going to register a user called John, and I'm simply going to go register. And the first thing it's popping me up is saying, hey, do you want to use hello? Well, it says the camera's in use. Well, the camera's in use because I'm sending my image as well to you. So I don't want to register it in hello. So I'm going to click cancel to that. And what it's doing now is saying, making sure it's you, touch the security key, and I've touched the security key. I can now log in, and it's saying touch the security key. I'm actually going to touch it incorrectly. So that's one touch. That's two touches that have been registered. I'm touching it again. And that's number 3. And it hasn't been able to read my biometric. So I'm just going to use the PIN I registered earlier. So when it's saying touch, it's actually saying verify yourself to the key. And then I need to prove my presence. That's when you do it that way around. Okay, so it's got the credentials stored for John, so Aurora ID and the public key. And don't be shocked if you already see credentials for John, because this is a site stores the credentials in a database for 24 hours. And if somebody else had registered John, you would see both. It's purely for trying out. What I want to do is try it again. And I want to do some other things. I'm going to say I want to use attestation data. I want to say I want to use a cross-platform authenticator. And then I'm going to say I want to use a residential key. So it's required. Now I'm going to register. Oh, please enter a name. So we go for John 2. And I'm going to register. And it's now saying a record of your visit to the site is going to be kept. That's because I've chosen a residential key. Continue on that. Touch your security key. It's not telling me about hello. So I'm going to touch the security key. That's done. And now it's saying allow the site to see your residential key. The reason being I said require attestation data. and that's it. So, and then of course I could log in again. I won't see anything different. It doesn't show me anymore. So that just gives you an idea, and this is purely generic FIDO2. Okay, so here in terms of white and blacklisting authenticators, you can do it. There's the enforced key restriction I mentioned, which is going to validate the attestation key all the way to root. And then I can restrict specific keys and I can allow them or I can block them. And if you allow or block, you identify them using the attestation the authenticator attestation GUID. If you block a security key, very nice, during registration, we detect the particular key type has been blocked by your organization. Nice, easy message. If you block a key post to your device being registered, what you'll end up with is this dialog saying, choose a way to sign in. Go to the security information on my profile. It's not an obvious message at all. And you need to be aware that if you do block keys after you've allowed them to be registered, well, number one, you're going to have to explain to the user what to do. They're going to have to go and register a new key of the correct type and delete the old key. So usage scenarios, what you've got is the ability to do second factor. So I can do username and password sign in. I get the challenge back. And at this point, all I do is I can just show presence. And I can then, having shown presence, I can send back a signed response. So I can support 2FA using FIDO2. But of course, if I've said I can also combine it. So I don't just show presence by touching the device, I can combine it by actually verifying against the device. The next thing is I can go passwordless. So now I username across, and this guy comes back with a challenge. And what I then do is I actually unlock the authenticator, sign the challenge, having got the user to verify against the and I send back the signed response. And then I can go finally nameless. So now what I do is I go start the login sequence and I get a challenge back. And now the challenge is identifying the relying party. And I'm going to have to look up what credentials I have for that relying party. So I look in the authenticator after verifying, and I might have multiple credentials. And this is an example here where we actually have 3 different credentials, and these credentials are stored in Windows Hello. I would recommend that you don't store credentials in Hello at the moment. The reason being is if you want to clean them out, it's actually just a little bit tricky. There is a way of doing it. You can delete the Windows Hello container, and you can use cert-util for doing that. But just occasionally, I mean, what should happen is when you go to log in again, the container should rebuild itself. But I have seen a couple of instances where it hasn't, and then you have to go through a troubleshooting process. So right now, I wouldn't put credentials into Windows Hello. But if you've got multiple credentials on a key, you just choose the one you want to use. Because I could have registered with a website using different credentials. Now, if we want to go for Windows 10 and sign in, let me just have a quick look, see if any questions have come up on that. Again,
no questions as of yet.
No questions. That's a good sign, I hope. And then in terms of Windows 10 sign in with a FIDO security key, recommendation is if you are one-to-one, then it's Windows Hello for Business. So that's how you sign in and you go passwordless, and that gives you a really great experience for AAD joined and also hybrid AAD joined devices. But if you want to go one-to-many, you can use a FIDO security key. So now I'm signing in with a FIDO security key and I can use that across multiple devices. And what you'll see is that once you've set it up, it will actually show you insert your security key into the USB port to sign in, and then touch your security key, which, remember, is not just showing presence. If it's a biometric, then it will be actually verifying you using the biometric. So if you want to go SSO to on-prem, if you're using sign in with username and password, what will happen is when we sign into Azure AD, we will get back what's referred to as a primary refresh token. That primary refresh token gives you SSO to everything in the Azure AD space. But when you want to go against on-prem, you have your username and password. So what you can do is you can actually do a Kerberos sign in using that username and password. So in terms of the user experience, it's a single sign on to everything in Azure AD. In Azure AD, we're using the primary refresh token, and everything in on-prem using Kerberos, we're using username and password. And of course, we can support NTLM authentication as well if we've still got that enabled. So that all works beautifully. If we're doing a FIDO2 credential sign-in, we don't have a username and password. So how on earth do we get a TGT? Microsoft have a solution for this. It's in preview at the moment. And what they do is using Azure AD Connect, they actually allow you using PowerShell to create a dummy RODC and an RODC KRB TGT account. And that's created by Azure AD Connect, as I say, using PowerShell. It's a dummy account, so there is no RODC. It's this. And what happens is the RODC KRB TGT key is taken, it's encrypted, actually it's double encrypted on its way up to Azure. It's then encrypted in Azure, and it's encrypted with a key that's only known to the Azure Evo STS. And now when it comes to sign-in time, we can use that. We need another component, which of course is we need 2016 or 2019 domain controllers. They'll need a patch on them. And then at sign-in time, we end up signing in with our FIDO2 key. We get a key for the tenant domain. So this is the ability to get the RODC key. And then it can generate a PRT, which would just happen automatically anyway, and a partial TGT. We can then send that partial TGT to an on-prem domain controller and get back a full-blown TGT. So we have single sign-on with Azure AD protected devices and also on-prem devices. And so that brings us to living in a world where we are passwordless. So in summary, a user required to create a password, absolutely no more. You don't even think about passwords. It's a cryptographic key pair. At some stage, we'll be able to turn off passwords in Azure AD. User reveals their password via phishing attack. Well, you could give away your private key if you gave away your authenticator and you gave away your PIN, or you gave away your finger for the biometric. But hopefully we can educate users not to do that. But if a man in the middle, so there's a phishing attack going on, and the man in the middle attacks can be very, very convincing, they are completely eliminated because of the ability of tying up the relying party ID and the origin. The target system holds a database of username and password, possibly KB questions and answers. Well, yeah, we can steal everything from the target system, from the relying party, and they're completely useless to the hacker. They get the public keys and some sort of randomly generated user identifier. So we really have come into a very nice way of eliminating passwords. I've got the websites I use. I use the web author NIO, and the other ones I put in there as examples as well. I've got a blog. Have a look at my blog if you want more details. And I have a masterclass which I run around the world, or used to, until COVID-19 lockdown things. I assume we're going to start again at some point, maybe later this year. Who knows? We'll have to wait and see. But I'd love you to join me on one of those masterclasses. And that brings me to the end of the session. Let me check the questions. And what have we got? Have we got anything come up? I don't think so. My mouse has got stuck.
I think you ended up answering the only question I had, which was about having multiple credentials for a different relaying party, and how they're stored on the authenticator keys.
Right. So this is multiple credentials for a single relying party.
Yeah. So say for example, I've got multiple Azure Active Directory accounts, a standard user account to domain A, an admin account as you would to domain A, and then domain B, domain C, domain D.
Yeah.
And I want to use those. I want to use the same key, physical key for all those accounts. So now I should probably have separated keys for all of those accounts. So that's something I'm getting to in time. But it stores them all nicely without having a jumble of, is it going to use key for domain C with domain A by mistake? Always my concern.
Yes, as long as because you're not supplying any user information, so the relying party, as in the Azure logon, is coming back and saying, "Hey, it's me," and then the key's going, "Okay, for you, I've got all these credentials." So yes, it works very nicely, and as I say, you can do it. You could do it in Hello as well, but I don't recommend putting keys in Hello at the moment because of the difficulty of clearing them out. So if there's any other questions, by all means, come off mute. I think anyone can do that, can't they?
Yeah, they want everybody should be able to unmute if you want to come and ask any questions at all, or drop them into the chat channel.
Yeah, no questions. Very interesting. Hope I don't have to get into the weeds troubleshooting it ever.
Yeah, well, it's in fact, I mean, if you look at those, I mean, we've got just a couple of minutes, haven't we? I think, Ryan, have we? Are we all right for a couple of minutes? Yeah, I mean, there's some actually quite nice, if you want to look at it and you're thinking of building, your own FIDO2 implementation, there's an awful lot of help out there. And I mean, there's the sort of passwordless one, which will allow you to simulate two-factor authentication, passwordless, but with a name, nameless as well. So, I mean, I could do just a very quick, so let's register a user called John. So, and this is because it's nameless, it's going to use residential keys. So I've got that message come up. Again, it's I haven't set it doesn't say use a cross-platform authenticator. So now I'm touching my security key. So that's successfully registered. And then what I'm going to do is I'm going to go, we'll go for John 2, register the user. Again, it's going to do a residential key, cancel that, and touching the key. And so I've successfully registered. So now what I'm going to do, we'll remove that, just to show you, if I go to sign in, it's logging in. And this, by the way, Sam and Jim, they are in Windows Hello. And to get rid of them, I'm going to have to delete the Hello container, and I can use cert util to do that. But if I go to the security key, so I've selected the security key, and it's asking me to touch the security key, so as in unlocking it. And it's showing me that I've got two credentials, John 2 and John, for this particular site. So there's a lot of different sites out there which will help you figure out what's actually going on. Any other questions?
It doesn't look like it.
Okay.
I think everybody was has really enjoyed that. Certainly learned something myself, and I've been using FIDO2 keys for a while now.
All right. Okay. Yeah, the FIDO2 spec's not the easiest spec to read. There's a lot in it. Oh, and by the way, yeah, if you see this, something went wrong. The request timed out. Do you remember as part of the whole process, you set a timeout, and because I didn't choose a user, it's failed. So it could not verify the assertion because I didn't choose the user. That was all. So if I signed in again, choose the security key, touch the security key, and then I'll choose John 2 and sign in. You've logged on successfully, but that was the reason the timeout came up. Oh, here we go. We got some questions. The question, lots of great. Thank you for that. Are there any courses I'd recommend? Well, unfortunately, I'm actually, if you're interested in the whole place around authentication to applications within the Azure AD space, I'm thinking of taking that content from my masterclass and doing it as online. Maybe if I let you know, Ryan, you could let people know if and when we do that.
Yeah, certainly.
But otherwise, yeah, it's a great session. People absolutely adore it. And I say it's in a lot of locations around the world. I'm not sure about going back to America at the moment, though.
Yeah,
but we'll see.
In regards to when this the recording of this session will go up live, I expect it to be some point between now and the weekend. There's a little bit of video editing that needs to be done between now and it going online on the YouTube channel. But I will let people know in the meetup when that goes live. We do have a 1/4 hour break between now and the next session to allow other people to join. And for James, who's doing his session on Azure Functions and I believe Function Monkey, which is how he's got to learn the intricacies of Azure Functions over the last sort of 6 months or so.
Yeah, we'll touch on that. Yeah.
Just stopping the recording.